All right, everybody, welcome back to the second semester. First lesson is about Pythagorean theorem, and I know you already know this, so I'm going to go through these examples relatively quickly, not show you all the calculator work. Just assume you can do some of this on the calculator. Um, so on this warm-up question, we've got both legs of a right triangle, and we need to find the length of the hypotenuse. And so, I guess I need to make this something other than white. We take one leg and square that. The other leg, square that, add those things together, and that equals the hypotenuse squared. And just because these directions say minimal calculator usage, I would turn both of these into mixed numbers. You should know how to do that. And when you square a fraction, you square the top and the bottom. And obviously, I'm not showing the calculator steps, but if you need the calculator for some of that, you can certainly use it. And then to add fractions together, you need a common denominator, which in this case would be 100. All right, now you can add those numerators together, and you get 25,281. And of course, we don't want n squared, we want n, so we have to do that, which means we do this. And the square root of 25,281 happens to be 159. And then just change that back to a mixed number. 15 and 9/10 is your answer. All right. Again, Pythagorean theorem is something I know you've seen before, so we're going to go through these pretty quickly. All right, now just like the warm up, we're down to the spot where we take the square root of both sides, and 340 is not a perfect square. So this is where you would simplify a radical. That's the same thing as 4 times the square root of 85. And there's your final answer. All right, this one's slightly different only because we know one of the legs, square root of 5. The other leg happens to be our variable, and the hypotenuse is the square root of 17. And this one's pretty easy. And just like the last example, 12, of course, is like 4 times 3. There's your final answer. All right. This one says find the area of each figure, and we just have to use a hidden right triangle in Pythagorean theorem to get there. So the hidden right triangle would be right here. And based on everything we know, this would be 6, this would be 4, and you push that over there, and that would be 8. And basically to find the area of this, I'll put area of shaded. That would equal the area of the rectangle plus the area of the triangle. I'll just put the S instead of shaded. Rectangle, of course, is length times width. Triangle is 1/2 base times height. Length and width of the rectangle, pretty easy. And the base and height of any shape are always perpendicular. So for the triangle, that would be 4 and 8. 8 times 6, of course, is 48. 1/2 times 4 times 8 is 16. And so your final area would be 64, what are we in, inches, so square inches. All right, here's a similar one. So again, what I would do first, based on everything you see there, is in the rectangle in the middle. We know that's 8. Subtract from 20, there's 12 units left over, but those congruent marks let us know that each of those is 6. And this time, the area of the shaded region would be the area of the rectangle in the middle plus the area of the triangle. I'll just put an L for the left side and an area of the triangle on the right for the right side. And in the rectangle, length and width, all right, we know one of those dimensions is 8. Doesn't matter if we look at the top or bottom, it's the same thing. So the trick is we got to find, I'll make it dotted, that. We'll call that H for height. And so before we finish what's in purple, actually I better not do that. Before we finish what's in purple, I'm going to change colors. We'll go red. And down below it, we need to do Pythagorean theorem just to find the value of H. And now that we know that, now we can go finish that original formula we started with. So length and width of the rectangle would be 8 and 8. For the triangle, since they're congruent, it would be 1/2 times base times height. And the other triangle, of course, is 1/2 base times height. Pretty easy from there on out. And so the total shaded area is 112 square meters. Basically, what I want you to take away from that is that a lot of times, not just in this lesson or this unit, but a lot of times this entire semester, you're going to have to go over to the side somewhere and do something with right triangles before you can finish the question. In this case, because it's all you really know so far, it's probably going to be Pythagorean theorem. All right. Last couple of examples. Find the area of each isosceles triangle. Now the trick here is one thing about special segments that I don't think we had time for before Christmas, and that is basically that in an isosceles triangle like this one, if you draw a special segment from the vertex angle to the base, if it's any of the special segments we studied, it turns out it's all the other ones as well. For example, if it starts off as an angle bisector, then you also know it's a median and a perpendicular bisector. Tell you what, let me change those colors. If everything in purple was given, then you could figure out what's in blue. Or, let's say you knew it was a median to begin with. Then you could figure out it's also an angle bisector and it's also perpendicular. And that's just the way it works with isosceles triangles. So that's one thing that we didn't have a chance to do before Christmas, but you'll definitely need to answer a question like this. So basically the trick is to drop down a height. We'll call that H. But since it's perpendicular, you can figure this out, making each of these 4. And the area of the red triangle, tell you what, let me turn this to red. The whole red triangle would just be, like any triangle, 1/2 base times height. And the base of the entire red triangle is 8, but we don't know the height yet. And that's like kind of like the last example where I said over on the side somewhere, you're going to have to do something with right triangles. And in this case, if you only look at half of this red triangle, one leg is 4, one leg is H, and the hypotenuse is 12. So if you do Pythagorean theorem with that, you end up with, what is that, 64 times 2, so 8 times the square root of 2. And that just kind of travels over here And now you can finish what's in red. So 64 times the square root of 2, half of that is 32 times the square root of 2. I forgot to put inches or feet or anything, so we'll just call it square units. All right, can't be afraid to work with radicals. You're going to do that a lot this semester. Which brings us to our final example. Working with radicals, it's the very same problem. Side lengths are in radicals to begin with, but that really shouldn't change anything. So here we go. Drop down a height, make it perpendicular. Turns out it's also a median. So each of these is only 3 times the square root of 5. For the whole red triangle, it's going to be, and the entire base, notice I'm putting 6 times the square root of 5, and just like before, we don't know the height yet. So for just half the triangle, we're going to do Pythagorean theorem. We're going to take one leg and square it. The other leg, square that, add them up, and that's going to equal the hypotenuse squared. 3 root 5 squared is like 9 times 5. And 7 root 2 squared is like 49 times 2. 98 minus 45 is 53. And the square root of 53 won't reduce. So there's the height that gets put into this set of parentheses. Whoop, forgot the square root sign. Right there. All right, and finally, you just have to work with radicals. And so if it helps you see it, remember, each of those can be thought of as fractions. Now you just multiply everything across the top. And 5 times 53 gives you 265. And of course, on bottom, 2 times 1 times 1. And the last thing to do is the 6 divided by 2. And believe it or not, the square root of 265 will not simplify, so that's it. And just like the last example, I forgot units. So whatever the units are would be squared because we're talking about area. So hopefully that will help you guys get through the assignment. Good luck with it. We'll see you later.